Hello and welcome to the Active Atom Educational Series. Part 3C, Assembling a Levin Closed Style Headstock. Hold on, take it easy, cautionary tale. Patrick has some very important information at this point before you go leaping forward and hurrying on to get your spindle going here.
Yeah, this is very important right here at this stage.
Yeah.
Because what we want to talk about is on these closed style Levin headstocks, Levin actually created 3 different designs through the years. Okay, and the three different designs we refer to is the first 2 designs we refer to as the early model designs.
Yeah.
Okay, and then the design of the headstock they ship today, we refer to as a later model design.
Yeah.
Okay, and that's really important to determine what model you have, because if you have one of the later model designs, then this part's for you and you can proceed. But if you have one of the 2 early model designs, you don't want to proceed with this part. We actually created a new part, which is part 3D. And part 3D is specifically for the early model Levin Closed Style headstocks.
Oh my, oh dearie me. Now we need to find out, did this just get really too complicated to understand and want to move forward like I'm lost here? Maybe Patrick can go a little further and explain what the difference is between an early style and a more modern style headstock.
Okay, no, good point. Let me first...
so we know what we're looking for.
That's true. Okay, let me first tell you how to identify, because to identify it's very easy.
Oh, good.
Okay, let me bring out the catalog, okay. Okay, the very first closed style headstock design Levin created was this model right here. Okay, see, before the closed style design, they had the open style.
Oh, my favorite. That's our favorite.
These are our favorite.
It just is. Still is to this day.
And this is the most common in watchmaker lathes.
Yes.
Okay, so after that model, Levin designed this one.
See that rounded top like a clock, I always call it, but it's really called a radius, right?
That's right. They refer to this as a radius top. Okay, so if you have one of these headstocks that have the radius top, okay, this was their first design, and you definitely don't want to follow the procedures in this part. You want to go to part 3D.
So yours is going to be a bit more challenging.
That's right. Okay, so now we're going to go to the flat style headstocks. So if you have one of these headstocks, how do you determine if you got an early model or a later model? Okay, that's really easy.
Because they look awful similar.
They do. So if you look at these, okay, these are 2 headstocks, and one's actually an early model and one's a later model. Okay, what you have to do is, okay, on the front, you know, you're going to have the plate right here.
Yeah.
You know, with the model number.
The little Levin made in California sticker.
And made in California, that has a model number and the serial number.
Yeah.
Okay, what you want to pay attention to is a serial number. If the serial number is below 10,000, you've got an early model design.
So you have one like that radius then. Like
That's
the radius
right.
headstock.
Exactly. Internally, it's identical to the radius top. So it's just
you
cosmetic.
don't get to have the fun rebuild. You have to move on to part 3D.
That's right.
Ouch.
Yeah, ouch.
At least it's solvable, though.
Yeah, so if your serial number is 10,000 or above, hey, you're good to go.
It's your day.
Yeah. So if you got a serial number with 10,000 or above on a D collet style headstock or a 3C collet style headstock,
life's good for you.
Yeah, life's good for you, because we feel it's one of the most, the easiest headstocks to rebuild by Levin.
Yeah.
Yeah. Okay, and let me just show you really quickly. Okay, so what is the difference? What makes this job more difficult?
Let's say you have one of these and your plate's missing. It could be.
That's right. Okay.
We've seen that, where people don't have a serialized plate. I don't know, maybe there's a chance they could figure it out.
That's right. Okay, so what's going to happen is, you know, you're going to remove your spindle. So here's a D collet spindle. Okay, so let's say you start disassembling your headstock. Okay, you're going to find 2 angular contact bearings on the front right here.
Okay.
Okay, and on the later model design, this is how the bearings are going to look. Okay, if you got one of the early designs, one of the bearings is going to look different.
Oh yeah, look at that.
See that?
Big flange on there.
Yeah, see the difference?
And even that groove there.
Yeah, see? So the front bearing is different.
Yeah.
It has this big flange length just identified.
It does.
And see, and so what they did was when Levin first designed this type of headstock, they designed it for this type of bearing. And this flange is really critical on the early design because, see, when this is on the spindle and then when you insert it, this flange is what
keeps it from getting pushed on out the back end there.
That's right, because see, if you were to replace this with just one without the flange, the spindle would go right through.
Yeah, it would shoot through there like a rock.
Exactly. Because see, if you notice, if we look at the inside, see, there's no step. See, so the bearing would go right through.
Oh, they're in. Yeah, it's just a clean hole through there with a big cavity in the center. Big
exactly.
opening.
See, there's a big opening, a big cavity. See, and if we look at the 3C,
more modern here.
Yes, it's more modern. See that step right there?
That's what holds those bearings from going on through like a rocket.
That's right.
That's making sense.
Yeah, and what happened was, see, when this bearing came out, this bearing type with the flange was only made by one bearing manufacturer, which was New Departure.
Oh.
And so the problem was only one manufacturer made this type of bearing, but then later on, they discontinued it. And when they discontinued it, there's no other manufacturers, so nobody could obtain these bearings any longer. So that's why nobody could rebuild these headstocks. And even Levin, if you call Levin with an early model headstock, they'll tell you they cannot rebuild it.
And that's why we have Part 3D. We've saved your day.
That's right. And that really bothered us.
It did.
Because if you watch Part 3D, you'll hear an interesting story of how we came across one. First a friend purchased one by accident, and then we actually purchased one by accident later in the years.
Yes, we did get stuck with one.
Yeah, we got stuck with one. So fortunately for you, because we got stuck with one, we're able to show you how we rebuilt one before.
And it works out really well, I think. So,
it really does.
So I think you're in luck here, and we're happy to be able to share such a rare event. Because there are you who need that done out there. And so there is a solution. We are proud to bring it to you.
Yeah, because there's a lot of early model
mostly
style headstocks out there.
I'd say there's more of those than anything. Huh?
Absolutely.
Absolutely. So we're really important for us to be able to have the opportunity to bring this to you.
Yeah. Okay. So if you've now determined that you've got a later model headstock, okay, now you can proceed. Okay, but we want to mention before proceeding further, we want to be sure that you've watched Part 3A, right?
Yeah.
Because, that's Part 3A, there's going to be a lot of procedures like the greasing of the bearings that are covered in 3A that we don't cover here because we don't want to duplicate,
these
a lot of the procedures.
Take enough time and from your
That's
day.
right, especially when they're identical. Although the 3A is focused on the Levin Accessory Spindle, a lot of the procedures, such as greasing the bearings, are identical.
This is mostly a series about processes and procedures.
That's right.
So it's important that you go back and watch the ones we recommend. Don't try to skip, please.
Exactly.
We just want to help.
Yeah. So,
that's nice.
Okay, and that's it. Yeah, so if you've got a later model headstock, you've watched Part 3A already, you can proceed.
Yeah, and you should have a good day.
Yeah, and you're going to have a fun, easy rebuild, we think.
And don't panic, 3D. We got you.
Yeah, we still got you.
We got you. Just a little more work, a little more research. But you got it. But we did it all for you. So you're going to be able to follow along well.
Great.
Part 3C, Section 1, Parts Review. Well, this one's really, really important. There's more to this than just meets the eye. What you're going to see here, besides pretty, sparkly, shiny parts that have all looked perfect, like they're brand new and from the factory, is because we've already worked on each and every one of these parts. Everything here is completely done. So we get this, we get our parts list, we start looking at it. Gee, is everything here? I think we're all ready because we're going into assembly. All of a sudden, I realized there was a part missing. And if you're looking here and you just, and we do this all the time. We've done a lot of this, not all the time.
You can see it consists of a lot of parts.
It does. And if, this is just a locking pin here, and I actually had this set aside for bluing, cold bluing actually.
That's right.
Which we covered in another video.
Exactly.
And I had blued some and had one more to do, and I realized it was still out there. I had to go catch it up because when we getting started for the assembly here, Pat, you want us to take over now because...
Yeah, what we're going to do is we're just going to do a quick parts review, just kind of go over all the parts necessary to do a closed style headstock rebuild or the assembly process of it. So that's what I'll do now. And just to reiterate what Lance was saying, see at this stage, all the parts should be pristine, should be cleaned perfectly.
They need to either been purchased and replaced from Levin or wherever you're building your spindle from.
Right, if you identify any worn parts, damaged parts,
maybe one needs a little machine work, as we've done in a few of our videos here, and just all the basic, making sure the threads are good and all the little parts and pieces fit, and it's going to be clean. So that way, when you go to assembly, it's like a model at this point. You're just going to attach all the pieces. You shouldn't be fabricating model parts.
Yeah, because see, what you don't want to do is you don't want to, for instance, be in the middle of the bearing installation where you're installing the bearings in the spindle, and then you're in the middle of the installation procedure, and you realize, oh wow, I'm missing a part. Well, I'm either going to have to machine the part, order the part from Levin or whatnot. And that's a really bad situation to be in because you don't want any of those delays because you don't want the bearings sitting open out of the package.
We talk about this being a timer.
Right.
It's like a timer. We've hit the little egg timer. It's ready to start, and we don't really want to stop unless, we got to stop a little bit once in a while.
That's right.
But you don't want to stay focused here and stay out in an area where you're kept out of things as we cover in part 3, 3A and all that. We cover it all the time.
That's right. Okay. Yeah, so let's do a quick review. Okay, most important...
They are really shiny and pretty parts, though. Somebody did a really good job. Patrick actually painted these, though. You did this particular paintwork.
Yeah, I did do the painting.
Yeah, it's really nice.
Okay.
It complements my work.
Oh, yeah, and as you notice, for this part 3C, we're assembling a 3C collet spindle. But if you have a D collet spindle, the procedure's identical. The only important thing, like we mentioned earlier, it just has to be a later model.
That's right.
Design.
And this is Levin's largest spindle.
It is. They don't make a larger. This is the largest, a 3C collet. So, and obviously the most important part being the housing.
This is your base you're going to build off of.
Yeah, so it's all ready to go. See, at this stage, it should be, cleaned. If you're going to paint it, it should already be painted like this.
Threads, all nice, everything.
Yeah. Also important is, this is the belt pulley cover. So you've got the belt pulley at the rear of the headstock. See, and the belt pulley cover fastens right, on the side right here. Okay?
It's nice.
So 2 important pieces. Okay, you'll notice we got the spindle right here. See, it's pretty large for a 3C.
That's a 3C.
Collet.
Yeah.
Yeah. See, as you'll notice our witness marks we made right here. And these are the witness marks we made where we measured the high spot on the spindle. And we discussed this in part 3. Okay, so really important. At this stage, you should have already identified the high spot and you should have these witness marks. And again, we placed 2 witness marks just as a backup in case we accidentally rub one off. We have a backup at the other end.
Because these remain on here all the way through the process, even if you have to revamp them a little bit along the way.
Right.
Until we've completely got those bearings installed and got it put in there. Then we take them off.
That's right.
Just in case. So you don't want to have to go back and find that high spot again. Oh my.
No, you don't want to lose.
We covered that really well.
Yes. Okay. We got the spindle nut with its fastener right here. Okay, we've got the locking collar. Okay, this is what locks the spindle in place. We got the bearing spacer. Okay, the bearing spacer kind of goes like this on the spindle. Because what happens is you've got your 2 angular contact bearings sitting in front of the spindle. You've got the bearing spacer with the locking collar. And then you got the deep groove bearing in the rear. And then the belt pulley. You got this and behind it. And then you got the spindle nut that's locking all those parts in place.
And that's applying your pressure on those 2 angular contact bearings.
That's right. That's what...
So you get no axial. Is that axial? Am I getting it right
axial.
Today? Axial movement there. Yeah.
No axial movement, which is this way.
There we go.
Yeah. Okay. So what else do we have? We have the bearing cap. you know, which sits in front and locks the front, locks the bearing pair, you know, so it doesn't move forward. Okay, we've got the 6 fasteners that go with it. We've got the...
Which are completely brand new fasteners, never reusing the fasteners twice.
Yeah, we
mentioned that a lot.
We mentioned that a lot. You know, fasteners are cheap, so we always, it's just a procedure of ours. We just always replace them with brand new fasteners.
Yeah.
They're cheap.
Yes.
Okay. So you got your slinger. You know, the slinger is what, you know, this is a...
Zing!
Yeah, this press fits at the at the front of the, this way. Front of the spindle shaft, okay?
Yes.
Okay, and then you got the cover. So this is a cover for the slinger. So it's a slinger cover.
And another round of little beauty screws.
Yeah, and its fasteners.
Yeah.
Okay. You've got the locking hardware. Okay, this hardware right here is what locks the headstock onto the lathe bed. Okay. Actually, I got the drawing right here to show you real quick.
I do.
See, so okay, so here's here's the I think they're called binding bolts. So see, this is what locks this headstock down onto the bed, and then you've got the really interesting how it works. You know, these are eccentric bolts, so this fits in here, and then when you turn this, it pulls these up onto the bed, and that's what locks it.
Sandwich that head to that bed, and it really holds.
That's right. And then you've got the springs. So the springs sit on top, so it's always putting downward pressure so it doesn't bind when you're sliding the headstock on the bed. Okay, you got the belt pulley. Okay. Oh,
and that belt pulley's got a little cover, doesn't it? It's kind of a 2-in-1. Is that how that sits there?
Yeah, if you notice.
I just like it because it's not another piece. It's that part of it.
Yeah, the belt pulley actually fits really tight and close right in the back.
It's well thought out.
Yeah. So it's actually providing 2 functions. It's actually a belt pulley, but it's also a bearing seal.
Yeah.
So it doesn't allow any, you know, foreign material to get into the deep groove bearing.
That's really neat.
Yeah. Okay. One thing you'll notice is both on the locking collar, you'll see a keyway, and on the belt pulley, you'll see a keyway.
Sure do.
And
right there and there.
You got the 2 keys right here.
There they are.
Okay. Really important, you know, these are really easy to lose. Believe me, we've lost 1 or 2, you know, doing these, and I'll admit, but they're really easy to replace. You don't have to go 11 and purchase them.
No.
All you have to do is purchase 1/16 inch key stock. And this is just steel, because I think there's different materials, steel, stainless steel.
Oh, sure.
We just get the steel version. And it's 1/16 inch square, okay? And this is really inexpensive, and most metal suppliers can get this. I mean, it's really widely available.
Yeah, because yours may be damaged for some unknown reason that's unknown to you from the past, or something may happen with the pulley one day.
Exactly.
So it's just something you have an option to do without costing a fortune.
Yeah, it's really easy. You know, you just cut it to size, you know, so you just cut it to size, deburr it, and you're ready to go. It's that easy. Okay. And lastly, the bearings.
Oh, the bearings.
You know, since we're doing a 3C spindle rebuild, these are the bearings of the 3C spindle shaft. See, and for the deep groove bearing, we're using 6005 bearings, and these are the 2 angular contact bearing pairs, which are 7205.
But that's only for a 3C, right?
Yeah, just for a 3C.
You've got a special place for them.
Right. If it's if you're rebuilding a D-collet spindle, it's going to take a different set of bearings, all 3. Okay, or the set and the deep groove is going to be separate,
okay,
a different part number. But if you still need to purchase them, you can go to our website, and we'll put a link, you know, under the description, and that's going to take you, there's a special section on our website.
On activeatom.com.
The activeatom.com, and it's a section just specific for the Spindle Rebuild video series. And one of the pages lists all the bearing part numbers for all the Levin spindles.
Pretty handy.
Yeah, I mean, that includes the accessory spindle, the open style headstock, closed style headstock, the WW collet, D collet, 3C collet, everything.
Everything's there.
Yeah. So if you're unsure, just go to that link and you'll find the part numbers you need.
Pretty good.
Yes, I think that covers everything. So yeah, so we got the bearings. Oh, one thing I want to note, this is the part that Lance was holding earlier. They call this the locking plunger. Okay, so see, this installs actually in front of the spindle right here.
It's just, this is what it actually locks into inside of there.
Yeah, see?
Indexes there.
Okay, so this is installed on the spindle. So when you push this plunger, see that pin right there? See, I can pull it, it's gone. See, when you push that plunger, it's actually locking into one of these slots. See, inside there. So that's what locks the spindle in place. And because this is the only case, only on these closed style headstocks, because this style of locking the spindle is really rugged, you can use this locking method when you're tightening the spindle nut.
Yeah, because this is the beefiest locking mechanism that Levin makes.
That's right. Unlike the open style headstock where you have that really
dainty pin with
a little tiny, really delicate pin, and you don't want to use that or hold on. You don't even want to hold on to the belt pulley because you've got a little tiny fastener.
Yeah, that little set's got a little special screw.
But this is a special case, and even Levin, I've spoken to Levin, and they've confirmed that they do the same thing. They use this locking mechanism when they're tightening the spindle nut.
They really stepped up their game, and it probably had something to do with the 3C collet. It was a bigger, just everything's getting a little bit bigger, and they had to get a little more aggressive on their ability to hold it.
Sure.
My guess.
Yeah, I would guess that too. So, and you'll notice, one of the things I just want to point out real quick is, you'll notice, unlike the other spindles, the closed style headstock spindle doesn't use any felts.
That's right. I'm felt free.
Yeah, you're felt free. So unlike the other like accessory spindle and the open style headstocks, you don't have to bother removing the felt with the felt retainer ring. You don't have to clean them. So that's another. So that's why this assembly process is much easier than on the other spindle types.
Yeah, I felt that. Could not possibly resist. Part 3C, Section 2. Preparing headstock for spindle assembly. And boy, isn't somebody looking sparkly and shiny today. I couldn't be prouder of her.
Me either. It is ready to start the assembly process.
Yeah, it is. It's beautiful.
But you know what's nice about the Levin Closed Style headstocks? Is there's no preparation involved.
Oh,
where we had to do for the Levin Open Style headstock.
You mean like the snap ring and those stud bearing nut covers, the spindle.
Yeah, the internal ones. Right, so there's
really unique to that spindle.
Yeah, just on the open style headstocks. Yeah. But fortunately on the closed style headstocks, there is no preparation. But you want to ensure, like we mentioned in the prior section, just make sure it's all clean.
Your threads are all good, and if you're going to paint it, you should have already done that by now.
That's
we don't want to be doing that after this sophisticated work we're about to perform here.
Exactly. So we're good to go.
Yeah.
Okay, so the next step is, now is the time to open your bearings, because as we've always preached, you don't want to open up your bearings until you're ready to lubricate them.
When I look at that into that camera and tell you no, it's really because I've told myself that because I've done it.
Yeah.
I'm being honest. And
we're anxious,
We've been anxious in the past, and we don't break the rules anymore.
Yeah.
We're looking at ourselves when we're talking to you. Okay, there you go.
Yeah. So what I'm going to do is, off camera, I'm going to go ahead and open up the bearings.
Good.
I'm going to lubricate them.
Right.
But we aren't going to share that on video because in, what was it? Was part 3A, which was for the Levin Accessory Spindle. We went into great detail on using the syringes, filling them up with the grease, using the special blunt tips.
Oh, boy.
And even under the microscope, we went to great detail on the application of the grease in the bearings.
We did, and there's enough to do, and enough you need to focus on doing that lubricating, because what we don't want, and I know we reiterate a lot of things a lot of times, is we don't want that bearing grease to cause that bearing to overheat during the break-in process. So what we're sharing with you is even for us, filming that is enough. Doing the work's enough for us. Filming on top of it was quite a bit more. We only wanted to do that once, and it's really important that you go watch that, because this is all the details that make the difference between somebody who does something good and somebody who's fantastically great at what they do.
Yeah, and you know what?
And we want you to be great.
Even if you've already watched Part 3A and you've watched that section, we highly recommend to go ahead and just watch it again.
Yeah.
And just right prior to doing this procedure.
Because there's a lot of little finite details there that we take for granted. And
that's right.
We want to make sure we just do the best to help you.
Great. Okay, so that's what I'm going to do. I'm going to go ahead and start the grease application procedure.
Great.
And when I'm completed with that, we're going to come back and we're going to install the bearings onto the spindle shaft.
Well, we're getting excited here.
Great. Okay.
Part 3C, Section 3, Installing Bearings onto the Spindle. Well, Patrick and I are back from greasing those bearings.
Yeah.
And boy, things are about to go just huge here. Levin just was going large at this time and space at their company. You know, we are always showing you this with the accessory spindle and the open head style.
Yeah.
Headstock, open style headstock. And now we're going to move to something bigger. We're heading toward that Barker Mill spindles before you know it.
That's true.
We're getting bigger and bigger.
But look at the difference. Okay, these are the SKF, bearing installation toolkit. And look at the size difference. So we were using this post to install the bearings for the accessory spindle and the open style headstocks. And now for the 3C, call it headstock, look at the size we have to jump to. And then along with the bearing.
Oh yeah, the little bits.
Dies, yeah.
Dies. So, but Patrick's going to share with you the difference in sizes of the bearings of the two we've done already types and the one we're about to do now. And I'm observing here. I'm a very observant man. I'm observing that we almost had to go to a larger dust cover.
Oh yeah,
we almost didn't make it.
Yeah, you guys have seen this before, where after we grease the bearings, we use our little. It's for watchmaking. When we work on a watch movement, if we aren't currently working on a part of it, or if we take a lunch break, you want to always keep that watch movement covered because you don't want dust or anything to get to it. So we have these dust covers. Okay. So same with the bearings. After we grease the bearings, we don't want them sitting on the table, and then have to, risk getting dust and hair or anything from the environment onto them. So that's what Lance was saying, but God, they just barely made it underneath
her dust tray. Bigger cake cover there.
Yeah. But look at the size difference of these bearings. Okay.
It's amazing, yeah.
Okay, when we did the accessory spindle assembly, that was Part 3A. This was the bearing size we used, the 7001.
It's a little tiny.
Yeah, a little
looks
tiny.
Like a skateboard or something.
Yeah, look at that.
Just little. Okay,
then when we did the open style headstock, and this is true with the WW and the D-collet headstocks. This is the bearing. So it grew pretty substantially, but still pretty small in terms of bearing, general bearing size.
These are used worn bearings. These are we just leave them around for samples.
Yeah,
to do demonstrations.
That's true. Yeah, these are used.
These are nothing to worry about. They're not going anywhere near a machine anytime soon.
Okay, and check this out. Just carefully. See, look at the 3C bearing. Look how large. So it's, that's why the SKF tools, that's why they grew so large, because just check out the size difference. Really, especially the difference between, for the accessory spindle. Boy, it's...
Oh, yeah, it's amazing.
Look at that. Oh, and just to show you, see, if you've greased your bearings properly, this is how it should look. So we got a nice, consistent... application really of the grease. So it shows you the back too. Let me put that back. Oh, you'll notice that I'm wearing a loop. Okay, for this section, we highly recommend having a loop. You don't have to, you can use, one of these loops, the general one, but I like to use this one because, I wear glasses, of course. And the reason for the loop is, as we're installing these bearings onto the spindle shaft, it's our last chance to look over the bearing really carefully to make sure, there isn't any dust or lint or maybe an eyelash, that fell while you're working on it. And if there is, this is your last chance, because when we install these bearings onto the shaft, after we get it all assembled, you're never going to see the bearings again until your next rebuild many years later. And remember, you don't want any foreign material in your bearings, because that's going to, that's gonna fail your rebuild. So really critical. So that's why we use a loop. And if we find any, like a hair or anything, you know, I either use tweezers if it's big enough, or in watchmaking, you know, we use this putty, which we call roticle. And if I see like a little, you know, flake of dust or something, you know, I just, you know, remove it by just tapping on it. And we use this, you know, in watchmaking to remove dust and foreign particles and watch movement.
And that's where this behavior of ours comes from. It's
yes.
Just what we do.
So really important. So let me put this back. Okay, the other thing we recommend is, as you saw in the prior videos, you know, we use a hockey puck. And we use this as our bench block. And you know, we use this where we put the spindle on top like that, and it's like our platform when we're installing the bearings.
Yeah, it is.
Because we really don't want to damage the end of the spindle. And it's perfect because it's the perfect hardness.
That's vulcanized rubber.
Okay, so
that's a process, and a patent was on that a long time ago, and it all goes back to Goodyear.
Oh, sure.
Just bear with me on that. Anyway, I like to share because we are always learning around here, and we just love to share it.
Right. And it's perfect. We love this because it's not too hard, but it's also not too soft. We think it's just perfect.
Yeah, it doesn't allow any damage. It's nice.
Yeah. Okay, and then I think last thing is, of course, you know, as we're assembling the parts now, you always want to be sure you're putting a coat of oil, which we use Nye oil.
We do.
But any good quality machine oil should work
Perfectly.
But we love our Nye oil, and you don't want to, again, we always preach, but you don't want to oil everything at once.
No, as you build.
As you build. And why is that?
Because it is like a magnet.
That's right.
And it will pull dust and particles, even little hairs and things like that from out of nowhere. And put it right where you don't want it.
Yeah.
And that's just what we do.
Yeah. Okay. Yeah, so I think we're ready to go.
That's it. That sounds really good.
So here, let me put these old bearings aside. Okay. Let's get this all set up. Okay, so put our bench block here. Okay. As you saw in prior videos, what I should probably do first is oil the spindle.
Yes.
And again, you know, we do, especially on the spindle shaft, I do like to put a little bit more oil than usual in this area where the bearing is going to slide on, just to assist in the...
And we put that on per bearing, right? We put 2 up there. We're going to scrape that off, probably going to scrape all that off, pushing down on there.
That's right.
We learned that along the way in the years, and it just makes it easier. I just want everything to flow nice.
That's right. Okay, I think that's good.
I feel good. It's a bigger diameter now.
Yeah, it is big. It just seems funny to work on such a big part. Okay, what I like to do anytime I'm doing a spindle rebuild, I always like to place the spindle shaft where the witness marks are pointed at me. That way I can just focus, you know, just a good habit. Just so I'm always aware to keep that witness mark on this side. And then I can always align it and be sure it's straight at all times. Okay, I think that's good. So let's see, just like that. Okay, remember, okay, what we're gonna do is, or maybe I should put it aside. Okay, so remember, we're gonna install 3 bearings. We're first gonna install the angler contact bearings. And when we install the 2 angler contact bearings, they're gonna install together as a set or a pair. But we can only install one at a time.
Okay.
You know, don't do both at the same time. So we install one first.
Okay.
Install the other one next to it.
Good.
And then once we have the 2 angler contact bearings on, then we're going to slide it into the headstock housing.
Right.
So, okay, so that's what we're going to do. Okay, the other thing is, remember, on all the Levin spindles, you know, that's from their accessory spindle and all their headstocks, the bearings are installed in a back-to-back configuration. Okay, and what that means is, if you look at the bearings,
These are bigger, so they have those fancy arrows on them.
No, I was going to talk about that. Okay, Okay, where you see the writing on the bearing, the writing's actually the back of the bearing.
Oh.
So because it's a back-to-back, these are going to be installed where the first one's going to be installed where the writing's going to face up. The next one's going to install with the writing face down.
Oh.
So back-to-back. Okay, the other thing is, okay, as we mentioned when we did the accessory spindle assembly, we mentioned that on the angular contact bearings, you aren't going to see those arrows that indicate the high spot in the bearings because they're too small. But on the larger bearings, you're going to see those those arrows. Okay, but that's not always 100%. In some cases, like these are pretty large bearings.
They're big enough.
Yeah, no arrows.
Oh, I took a shot that they had the arrows.
Yeah, and they generally do. I think these may be a little older.
Oh.
So I think years ago, they weren't putting the arrows on the outside surface yet.
So we're just doing it through the writing.
Yeah, so instead of the arrows on the outside, what you got to do is you got to look for the asterisks.
Is that what they use there? Okay.
Yeah, it could be different per manufacturer. SKF use asterisks. Some bearing manufacturers, they'll use the letter O.
Yeah.
You know, or a dot.
Yeah.
So yeah, and then in SKF's, you'll notice there's here on the outside bearing race, it has -4, and here it's -3. What this means is the tolerance of this bore right here is -3 microns.
Okay.
So it's 3 microns smaller than spec. Okay. And then same with the outside diameter, it's -4, so that means
It's going to create a little more resistance going on.
-4. Yeah, especially on the bore. Yeah, keep that in mind. You know, the larger the number, the harder it's going to be to install these bearings.
So it doesn't mean you're doing anything wrong.
Right, especially if you're doing multiple spindle rebuilds.
One might go and one may not.
Yeah, one may. You know, on one spindle, the bearings may go on really easy. On another spindle, it may be really much more difficult. And it's all about the tolerances right here. But you will notice that's what's really important about buying, you know, a duplex pair or a set of these angular contact bearings is that the bearing manufacturer will match these numbers for the two bearings in the set.
So they're going to go on with the same amount of resistance.
That's right. And it's really important that, you know, you don't want two bearings that work in a set with different tolerances because one's going to work harder than the other.
Somebody's going to be required to do more work, and that's going to result in a little less longevity of the spindle.
That's right.
It's not going to help it.
Okay, so what we're going to do is, so we're going to install this one first. Okay, what I like to do is, because we don't have our arrows out here, I like to get a permanent marker and just make a mark on the outside. Because what's going to happen is when we install the two bearings together back to back, our faces, we aren't going to see the faces anymore, so we aren't going to know where that high spot is. So can you hand me a permanent marker, Lance?
Oh.
Here, why don't you?
There you go.
Okay, so that's what I do. Okay, see, so there's an asterisk right there. Okay, see, just like that. Okay, then remember, okay, so what we want to do is, when we made the witness mark on the spindle, this indicates the high spot that we measured on the spindle shaft right here.
That's its high point up there.
Okay. Now the asterisks, the manufacturer put these asterisks here to indicate where they measured their high spot on the bearings.
Yeah.
So what we want to do is we want to put their mark opposite, so 180 degrees from the witness mark we made. And the goal is we're basically trying to cancel each other out.
That makes good sense.
Doesn't that make sense?
We don't want to put them on the same side
because that would add on to the.
It's gonna make it. It's gonna double our problem.
It's gonna double the problem because you're taking the high spot on both and adding to it.
So you're doubling, amplifying.
You're doubling it. See, where if it's 180 degrees, we're taking away from it, so we're trying to cancel each other out.
And you know it's not going to be perfect, as you mentioned many times. It's just to take out the bare minimum, what it possibly can.
Right. We're just trying to get the best accuracy we can.
And that's what this is going to do. So pay real close attention because it's really neat.
Okay.
Come on.
Okay, remember, I'm not paying attention. I should probably mention, at this point of the installation, I'm not paying attention to the marking on the outside bearing race, just on the inside bearing race. So this marking right here.
That's not committed on the outside. Just
not yet. You know what I'm going to do, because these are larger, let me just put a little oil.
We know it's -3 too, so.
Okay, so yeah, I just like to put, oh yeah, I was noticing on my other set, because I have a backup set of these, and on that one it's a -2. So see, if I would have used the other set, they would have been easier to install.
A little bit easier.
Yeah, a little bit easier. Yeah, it does really make a difference, I've noticed. Okay, so I think we're good. Oh, this is where we want to use our loop, and this is our last chance just to make sure there's no foreign particles. Okay, now looks really good. Okay, now I see just a little, looks like a little dust particle right there. Good. Yeah, especially for the little tiny specks, this reticle really works great. Yeah, I think that's good. Good. Okay, so let me get this lined up. Okay, this is going to require the larger. Okay, make sure. Good.
So the writing's always the back.
Yes.
Okay, so the writing's always on the back of the bearing. That's a standard.
It's a standard.
Okay.
Yeah.
I just want to be sure.
Yeah, this little.
You need to make sure of this, and I'm going to say why. Because once he hits that once, it's not coming back off.
No, it's not.
We're going to just ask that question one time.
Just to show you this other bearing die. This is actually for a deep groove bearing. You'll notice the deep groove bearing's a little smaller diameter.
Oh yeah.
See, that's why we need this one. Okay.
Yeah, it is smaller in diameter. I see it over there in the.
Yeah. Okay. Are you ready?
Yeah. You want me to hold the base?
I think I'm good.
You okay to do that?
I do stand up for this operation because let me just, I don't want to hit anything. Okay, I think I'm good. Oh, that went great.
That went right on.
Very nice. You just never know.
God, we've had smaller ones have harder time. I think it was open style headstock.
Yeah, sometimes
a little bit firmer.
You can never predict. I've had those little accessory spindles. Boy, it'd be really difficult.
Wow.
Yeah, you just can never. But you know, it all has to do with all the different tolerances.
Yeah, the spindle itself.
Yeah. Okay, no, that you can just. I always just every time I do install one bearing, I just always like to make sure it installs all the way. So with my
because it seats right up against that nose, right up against that spindle nose.
That's right. Okay, no, it looks really good.
always double check and make sure that the
Oh, you're right.
that the alignment that when you hammer down and it went kind of quick, it didn't slip.
Okay,
rotate it all.
I'm really glad you mentioned that because that does happen once in a while. Okay, what Lance is saying is, okay, so after we installed the bearing, you know, we've got our witness mark here, and we just want to make sure that after the installation, we've got the marking,
That it
the
stayed
witness
true
mark.
at 180 degrees.
Yeah, from the manufacturer right there.
And how'd we do?
So here, it's perfect. Okay, sometimes
it does move.
It does move. It will shift a little. Okay, if that happens, nothing to get paranoid about. Because remember, this isn't perfect.
No, it's not.
We're just trying to accomplish the best possible. Okay, so if it just moves slightly, it's not.
Don't mess with it.
Yeah, don't mess with it, because you don't want to try to remove the bearing again. Once it's on, believe us,
that is close enough.
It's close enough. So if it does shift, I mean, obviously, if you accidentally get it to where you match the two witness marks together, then
you are going to need to work on it.
Yeah, you're going to have to work on it. But if it just moves slightly, you know, what you do is make a note of that, and when you install the second bearing,
match that.
it.
Don't let them fight each other.
Yeah. Don't try and match the second bearing now to the witness mark on the shaft. Match it with the first bearing you did.
I like
That's
that.
more important.
That's a great tip.
Yeah. No, because it does happen. It's happened to us, so. Okay, good. Okay, so now we're going to prepare for the second bearing. And we just, like Lance mentioned, we just like to, you know, apply the oil again, just because, you know, the first bearing will, you know, move most of the oil down.
I think that helped that you oiled the inside of that race myself.
I think it did.
It went on awful easy. You know, that was really neat.
Yeah, it makes me happy when they go on nice.
Yeah, I don't really like pounding away on stuff at all possible.
No.
I don't want to fall on either. Right in that middle line, a little sweet spot there. Whatever works, so we'll do it again.
I never do this in the smaller.
That one.
Yeah, I will after the oil. I never do this on the smaller bearings. Yeah, just on the larger. These larger bearings scare me.
Well, we're not used to them.
I'm just kidding you, but no, it is.
We're usually making bearing bits smaller so they'll fit our little itty bitty bearings around here.
Yeah.
And not having to use the bigger ones at all. They don't make them that small.
Oh, there it is. Okay. There was a little dust speck.
Yeah, because these are going to clamp together. Then we're going to see the light of day again. That's going to start that pressure building, right?
That's right. We're going to never see these bearings again. So this is our last opportunity to make sure they're perfect. Yeah, because we keep mentioning, if there's like a little, especially a hair, like an eyelash, if it gets in there, you're definitely going to feel it, and it's going to really bum you out. Most of the time, it's not going to go away.
No.
You don't want that scenario. Okay, that looks good. Perfect. Okay, let's make some witness marks there.
Okay.
Okay, can you...
It always pays to have
permanent marker?
Second set of eyes.
It does. Okay, it's just like the other one. I just want to... Okay, right there. I made a mark with a permanent marker to match the marking from the manufacturer, the outer race. I did the same thing on the inner marking. See, the second bearing, we're going to install it with the print face down. So once it's installed, we're never going to be able to see these markings again. But with this mark, after the installation, we'll be able to use our new mark to be sure we got 180 degrees.
And at the same time, you mark the outer so you know those stay in their same
That's right.
world together.
Exactly. Okay, so with the witness mark on the shaft facing me, just like that. I think we're good. Okay, I just want to see.
Make sure we don't rotate it all, right?
I just want to see oh, perfect.
That's doing good. Really good.
Really good.
It's almost home.
Okay, I just like to give it one nice, good. Okay. I just want to be sure, because it's, you know, these are angular contact bearings, so I just want to be sure they're seated very well together. Okay, great. Oh, and we see we can now see, okay, my witness mark's right there. Perfect. See, my witness mark's right here, and we've got the mark in
That's really nice.
erase right there.
Really nice.
So great. Okay, here.
I'm going to keep those in line as close as possible. There you go.
Perfect. Yeah, that's what you want to do. So we just want to line these two up.
So those are the two outer raised high spots.
Yeah. And so when we install this into the headstock housing, okay, these markings don't have to be in any specific place in relation to the headstock housing here. Say what I mean is, see, I can install this
any way you want.
Any way you want. I always just I don't know, just out of habit, I always install it with these witness marks facing straight up. But what's more important is that these match between the two. That's all that matters.
Good.
Okay. Okay, so let's just go over it, make sure. See, we can do the field test.
I'll start our little practice spins.
Yeah, this is where now from this time on, we'll be spinning this every time we do anything.
See if anything started to bind.
That's right.
At each process, so you know where it started, where it happened.
See, so this is our first test, and see right here, it's perfect. Feels silky smooth, and already because the two bearings are seated, because I made sure they're seated very well together, you can already feel the resistance, which is what you want. See? Didn't it feel nice, smooth, tight?
Yeah, that's nice. Like when you do all this work, you can't wait to get a hold of it and give it a try there.
Yeah, so you feel no play.
No, it's really nice.
It's really tight, smooth, silky smooth, but with resistance. So perfect. Oh yeah, for those that are wondering, this is the spindle shaft where we did the collet key replacement in part 3. So yeah, so it worked out really well. So this one has a new key in place.
That's that key we did. Oh, okay.
Yeah. Okay, so good. Okay, now here's our front. And just make sure, just a light coat of oil. I also get the oil on the inside cavity, just because remember we're doing this as a rust preventative as well.
Yeah, and this is going to be closed up for decades to come. So
for many years.
Yeah, hopefully decades to come.
Yeah, hopefully
always shoot for that.
Yeah, hopefully decades. Yeah, depending on how hard you're running your spindles.
Yeah,
but it's going to be a while. So yeah, so there, you got it on there. Okay, good. Okay, again, I just want to make sure we don't have any lint or anything. No, looks really clean. I don't see no lint or foreign particles or anything.
Check that other bearing after pounding it on there, huh? Probably, huh?
And I also like to check the outside of the bearings. Make sure we don't have any dust, anything. See right there, I think I see a little speck of dust. Okay, looks really good. Nice. Really nice. Okay, what I want to do is just a really light coat of oil on the outside.
Pretty close.
That's good. Okay, this one's a little tight.
Yeah.
Yeah, you know what? You know, this is really surprising because I'd say the great majority of these especially these closed style headstocks, usually it's just a tight slip fit.
But you know, these are the largest bearings. I just wonder if it just doesn't make it any easier on us. But then it's easier to push too, so.
Right. You know,
yeah,
it could be the tolerance of the bearings.
Yeah, it could be.
Remember, we were just talking about that.
Yeah.
That every set has different tolerances. Because, you know, I got the first bearing in, as you can see. But I just
didn't quite get to start the second one.
Yeah. And you really don't want to force it. You know, but I'm really surprised because usually, especially with my palms, I can almost always get them fully seated inside the headstock
Which
housing.
is safe to do.
Yeah, which is safe.
Fine, you're fine.
Yeah, you're fine with that. But what you don't want to do is you don't want to pound this.
God, it just needs a little help. You just give that a little tap there.
Don't be.
No.
Yeah, whatever you do, don't. You know, I know it sounds really. What's a few taps really quick? But see, what's going to happen is you tap this. You're risking putting dents and
I call it bruising the balls area.
Yeah, and even the raceways.
Yeah.
You can damage the raceways. And you may not see the problem immediately, but it's definitely going to shorten the life of the bearing.
Yeah.
So let me do this. You know, we usually don't need this tool, but we have made a tool out of Delrin for just this purpose. So let me go ahead and find it.
Well, at least it's a little bigger than we're used to. We should be able to find it.
Yeah, it's pretty big. So we'll be right back.
Okay, we're back, but I'm not going to misdeceive you here. It took a lot longer than we thought. Of course, the bigger the tool is around this place, the harder it is to find, because we're so used to finding everything that's this big. So, Patrick, why don't you explain why that is?
Okay. Well, you know what? For the life of me, I could not find the tool. But the problem is, I mean, it's been a while.
It's as big as a headstock.
You know, it's been a while since we've done a 3C.
Yeah, long
But not only that is, it's a tool that for any of the headstocks, you usually will not need this tool. And that's why we're going to show you the tool. And that's why we're going to tell you, don't turn one, don't make one, because it's really a case-by-case basis.
We didn't need it.
Yeah,
we needed it, but
most
we normally wouldn't need it.
Right, most headstocks, we do not need this tool. So anyway, I could not find it, and I tell you, I was so tempted. It is just so tempting just to tap this.
And nobody will know.
Yeah, and you know what? Just don't, because we're
not going to get that life out of it.
Ruin it. Yeah. So we went out into the machine shop and made this tool right here.
We happen to have Delrin that size. I'm going to tell you right now, it's not normal around here.
Yeah, thankfully.
Our Delrin's usually as big as this. That's pretty much what we use.
Exactly. So fortunately, we had the stock of Delrin in this size. And it's a really easy tool to make.
Yeah, in case you should have to.
Yeah, you have to make this tool. And this applies to any spindle. If it's a WWD, call it, or 3C. There's basically just two dimensions you have to be concerned with. Okay, the inner dimension right here for the bore is basically the dimension of the spindle shaft head right here.
Loose.
Yeah, but loose. You know, you don't want, so see it's loose. It's tight.
Just a little bit of a guide.
A little bit of play. You know, you just want a little bit of play, but it shouldn't be a...
And it gives you a nice guide to kind of keep it.
Yeah, it keeps it, you want it to keep it centered.
So we're out to hit this outer race there.
Yeah. Okay, and then the outer diameter here, you just want to match the diameter of the bearing. You know, just like this, see? Just in case, the reason why you want to do that for the outer diameter is because just in case the bearings go into the housing a little bit, yeah, you want this tool to be able to go inside that housing.
Well, we don't want it to stop short and think
right.
that that's all it does because it's got more room or something.
Exactly. So there you go.
Very good, very good.
So
catch.
yeah, so not too difficult. You know, fortunately, this is a pretty easy tool to make. And so let's give it a shot. So Lance is going to hold the headstock. I'm going to hold it like that. However is comfortable for you.
Go right out on that edge there, I think. Got that in there pretty good. Can we share it or?
Can you? Okay, there.
I can't do much there. Let me do this. It's okay. You just go. There it goes. Second bearing's entering. Second bearing's in, going.
Let me just stand up. Okay, here, let me. Okay, good. That sounded really good. I think, let me just double check, but I think that looks good. Okay, because, okay, see how the bearing's still sticking out? We actually want that. And let me just verify, though, to just confirm that it is
that's
seated
as far as we can get down in that.
Okay,
casting.
yeah, it definitely seated because I could tell, you know, with the step on the inside.
Good.
So it definitely seated all the way. So it looks really good. But this is how you're going to confirm 100% that they are seated. Okay. Okay, remember, this is the bearing cap, you know, that gets fastened and holds the bearing pair right here. So you've got the step inside the headstock on this side and the bearing cap on this side. That's going to hold that bearing pair in place, which holds the spindle in place.
That's
you have
right.
no axial play.
That's an axial play.
That's right. Okay, so as you see, when you see, there's this recess right here. So see, the bearing's going to go in here. So that's why it's not a flush fit. Okay, but how you can determine is with this on, what you do is you just hold
up to the light.
Hold like this and hold to the light. And you'll see a gap.
All the way.
Very hard, but you definitely want to see a little gap. And the purpose of that gap, see, just like this. See, it looks like it's touching, but it's not. There's actually a little gap because when you fasten this cap on, you want that tension, you know, on the two bearings.
Yep, you want to apply
because
that.
if this is flush, there's a chance that your bearing pair will have play in there.
And we want that pressure against
That
those
pressure.
triangular contact bearings into that groove, into that slot there.
That's right. Exactly. So that's perfect. That's
Countersink there, really.
That's exactly what we want to see. Okay, so good. So, but we aren't going to put that on yet. Okay. Yeah, that looks good. Okay, so let me set this aside. Let me get the drawing real quick so I can kind of show you the
that's a good
parts. Okay.
That's it.
Okay, so here we go. So here's our two bearings right here.
And we seated them all the way down to that little corner right there.
Yeah, see there's that step right there inside the headstock housing. So they're resting right there. And so you can see the bearings right here, they stick out a little bit beyond the housing. So it's perfect. See? Okay, so what we need to install next is we got our our bearing spacer right here. Okay, then so we got to insert that onto the spindle shaft. Okay, after that, we got the locking collar.
Yeah.
Here, let me bring those parts. Okay, so here's our, let me match the drawing. Okay, it's just like that. Okay, so here's our bearing spacer. The locking collar. See, so just like that. See, just right like this.
Yeah.
Okay, remember the key. We have a key. So make sure, you put the key in, because that won't do you any good, else this will just spin on the spindle and it won't lock the spindle in place. Okay, so we got the key. Okay, then after the key, then we got our deep groove bearing. And then we'll use, and we'll have to switch the bearing die. So when I do that, put this one on.
Sure.
So get that ready. And and that's it. And then, so once we get the bearing installed, that will complete this section. So Okay, so I'm going to set these aside real quick because what we want to do next is we want to install just the bearing cap.
Yep.
Okay.
Let's lock that in place.
Exactly. Let's lock this in place, and then we can focus on the other parts, because what we don't want is, we don't want this, you know, to, because we may be, especially when we're pounding the deep groove bearing in, we don't want these bearings to come out.
We do not want to knock on those bearings.
No.
Yeah, no.
Okay.
Great cap's got lots of fasteners.
Yeah, it does.
Real rigid.
Okay, I'm just checking. I just want this area really clean, because remember the bearing right there is resting right here on the cap. So I don't want, you know, no, you know,
you
foreign
want to apply
material.
a little oil here?
Yeah, I'm actually gonna apply a thin coat of oil
a little bit right here, because it's the last time you're gonna see there.
Exactly. I think it's pretty clean. Okay.
And this is symmetrical. This has no positioning, right? This is a...
That's right.
It's only the slinger cover that has a positioning issue.
That's correct. Yeah, so Lance is referring to the slinger cover where, say, it has a little notch.
That's for the drain. The
And that's a drain.
Yeah.
Exactly.
This is just symmetric. It doesn't matter what you do.
That's right.
For once.
Yeah, for once. Okay, we have a nice coat of oil.
Looks good, yeah, looks nice. That's a nice part.
Yeah, this bearing cap's actually a brand new part that we purchased from Levin.
I wasn't going to do that. I was going to say it's because I cleaned it so well. I reworked it a little bit.
I let out the secret, huh?
Yeah.
Okay. Okay, then remember, I always... You know, when we do these spindle rebuilds, we always see rust or corrosion on the fastener threads. That's always
one simple little drop, one little second later, and you got this little thread's going to have
exactly
a layer of oil all the way down. It's sealed on there.
That easy. I'm putting these on like, you know, I'm putting lug nuts on a car tire.
Oh, okay, star pattern.
Yeah, I'm doing this,
yeah,
the star pattern, exactly. Because remember, it's, you know, there's that gap, so we don't want it to be too tight on one side.
It's going to equalize it and casually make it till it's firm. Be really nice.
Exactly. Okay, now I can tighten it.
It's nice. It's like brand new. It's so clean. You don't hear any grits or anything with the threads. It's just nice.
Yeah.
It's like the day it was probably maybe even better than the day it was built.
Oh, yeah, it looks nice.
Isn't that beautiful?
Okay, remember, always give it the test. Make sure.
Spin that spindle.
Yep, smooth. Nothing's rubbing. Nothing's binding. Feels good.
So we know before we put the deep groove bearing in that everything was perfectly fine and spinning well.
That's right.
If you put the deep groove in and all of a sudden something's bound, then it's going to come back to the Either we didn't do something right in advance, or something's wrong with that deep groove bearing.
That's right.
Or its installation's cocky, or something's not right.
Yeah, because we always preach that. You know, you don't want to be installing like 5 parts, then test a spindle, realize there's a problem, and you're going to think, well, which one of those 5 parts, you know, was that caused the problem?
You see how he's oiling each part only when it's time to install it? That's what he's doing today.
Yeah.
There's the little press sleeve.
Okay, now next we'll oil the locking collar.
Okay, but don't forget the key.
Oh yeah, that's true.
Before you go sticking that in there and then realizing it's going to spin pretty freely.
Oh yeah, can you imagine assembling the entire headstock and forgetting the key?
And there's nothing you can do about it.
Yeah, you'd have to, oh, that wouldn't be
You'd have to order another bearing, at least.
Yeah, the deep groove bearing. Yeah, that wouldn't be a good situation.
No.
Okay, yeah, because what I always do, okay, I still have oil on my fingers. I'm going to use that.
For that little key.
Yeah,
and I mean, that is a little key.
Okay, then what I do is I like to install the key on the part before I install it on the spindle shaft. So I'll do that now. Just like that.
That looks nice.
Oops, okay. Okay, really important is the orientation, you know, because you don't want, you actually want to insert it with this, the locking collar part.
Yeah, I call it the indexes.
Yeah, the index.
It's not, but it is. I mean, it's just locations, and you have a little print for that.
Yeah. Okay, so see, as you can see, so we already inserted the bearing,
Sleeve.
the bearing spacer.
Okay.
Okay, so the bearing spacer's in there. Now here we've got the locking collar, and so you can see the part with the index, it goes in first. And the way you can confirm that too is, here, let me install this. Okay, so we're gonna install it like this, really carefully. Okay, it should go on very smooth. Again, both the bearing spacer and this locking collar, they're slip fits.
Yeah.
So you don't need to pound it in. Okay, so I'm just pushing it, I'm just pushing that locking collar all the way. And then what you can do is just tilt your headstock and see if you see through, see the plunge, see that that plunger to lock the spindle, you know, gets installed right here. So you just want to make sure that right through this hole.
And it's a straight in line to the hole, so
that's right.
It has to find the slot.
That's right.
In there.
So you just want to be sure that when that pin gets pushed, if that collar nut is right there.
That's really good.
So
that's a good double check before you go putting that that deep groove bearing.
Yeah, it is a good double check. Okay, so that's good. So that's done. Okay, next step is to install the deep groove bearing.
Wait, oh, before you take that dust cover off.
Sure.
Okay. That locking collar that you just put in.
Yeah.
If somebody's doing this right now, they might go, wow, his locking collar looks like it's brand new. It has no wear, no accidents, no...
Oh, yeah.
Tried to turn on while it was locked in or something.
That's right. It did look brand new because it is brand new.
So maybe, yeah, well, you do have it.
Yeah, I still have it here. Yeah, this is the old one we replaced because we were just talking about it earlier.
It's rounded and it's...
Yeah, look at... This is really old. And you can see this is due for a replacement because how this works is, see here's the plunger pin. So from the outside, you know, you're pushing this in and that's what locks the spindle.
And it finds one of these 6 on the...
Exactly. See, it has six of these slots that you can push into. And this locks the spindle so that way you can lock it and when you're inserting like a new collet or something.
Get a good grip.
Get a good grip. And even if you want to do like a simple indexing, you know, for whatever reason, you can use it for that too. Okay, but so anyways, you can see, so after a while, you know, sometimes it rubs, you know, because you don't have it, you didn't pull it out all the way. Because remember, you're doing part after part sometimes, and then changing collets.
Machines.
Right, and sometimes, you know, we're just human, and you can kind of see, you know, sometimes.
So yours might more than likely look like this as opposed to the one we just put in.
That's right, exactly.
That's what we wanted to be sure.
Yeah, because Lance is right. You may look at ours and go, God, that one looks brand new.
Yeah, those guys don't work very much.
So yeah, good point.
Okay, back to your bearing, I guess.
Great. Okay. Well, our last bearing. Okay, let me show it to you. Oh yeah, this is a good example. Okay, this bearing is what's the this is that Swiss.
I have it here.
The Swiss-made bearing. This is the IBC. Oh. Or no, I'm sorry, you're right. It's this one. This is an RHP Super Precision ABEC7 deep groove bearing, which is this one. Okay, yeah, it's actually the IBC that has a different style.
This little fella's made in England, huh?
Yeah. And if you notice, like the last headstock we assembled, it was the open style headstock. And you'll notice it was from IBC and had a different cage design. See, this is actually a cage. It's not a cover. And it's, as you can see, it's reddish. It's that fabric reinforced phenolic resin.
Yeah, very good.
Okay.
It's a tongue twister.
Yeah, it is. As you can see, that little opening. So some of these bearings, can be a little bit more difficult to inject the grease into the bearing. So that's why it becomes so critical, especially like bearings like this, to have the syringe. Yeah,
you got to get in there.
Yeah, and just a note, sometimes like I always recommend using an 18 gauge needle, a blunt tip, needle or tip. This one, I believe I had to use a 21 gauge just to get a little smaller, and it worked perfectly fine.
Maybe so they can't tell on camera, but I can tell you it's a pretty close little gap there.
Yeah, it's really close.
It's the closest of all of these so far.
Yeah, because what you don't want to do, you don't want to be injecting grease and have it go all over the surface. You want it inside the cage.
We need it inside to work its way out.
Yeah, with the raceways and ball bearings and all that. Okay. Okay, on the deep groove bearing, remember, there is no orientation. It can go either way. Okay. But what I always like to do, I always like to insert the bearing with any print. If there's print on the bearing, I like the print to face outward.
Might as well take advantage of being able to identify it later.
Exactly. If we have to identify it, we don't have to disassemble it, because we do the same thing with electric motors when we're changing the bearings. Always the print on the outside for the same reason. Okay, so on this bearing, see, some bearings, they don't put the print on either side. Okay, there it is. Yeah, some bearings, especially these days, they'll laser engrave on the outside. Okay, but in this case, you can lightly see it right here. So that's what we're going to do. Okay, but before I do that, let me just set this aside. Okay, I want to just put a really light of...
A little bit of an assistant.
Yeah. Exactly. Give it a little assistance. And always just a little bit on the outside of the bearing. Okay, and if you remember earlier, I already put a little coat on that.
All the way through that housing. Yeah.
Exactly, throughout the housing. Okay, so that's good. Okay, then as always, I just want to check the bearing, make sure there's no foreign material, dust, whatnot. And that side looks really clean. Okay, that looks really good. I think we're ready.
Print facing out, that's good. Just double checking.
Yeah. Oh, and remember the deep groove bearing, just a reminder, we don't have to align any markings.
Yes.
Most super precision deep groove bearings have no markings. I believe I mentioned that in a prior video, where I think the only bearing manufacturer we found that marked their super precision deep groove bearings is Timken.
Oh, okay. What's the line they put here then? Or I'm just going to ask. I don't know.
I don't know. You know what?
I'm just asking a question. I don't know.
There's no me, because what would be really important to us would be the marking on the inside bearing race, because that's where if there was a marking on the inside race, that would indicate the high spot.
And we had to place it accordingly.
Exactly. But see, as you can tell, there's no markings there, no markings on the inside bore, and no markings there.
That's good and refreshing
to know. But see, See, there's a B there.
Yeah, there's a B on the inside too.
Yeah, yeah.
I just ask questions so
exactly.
somebody else might see this and go, "What's that mean? What's that mean?"
Exactly. Like, I think you missed something. No, that's fine. And that, I think that's just a manufacturing. Yeah, I could tell that's from manufacturing.
Okay.
No, but then, no, that's a good question. You know. So, okay, print outside. Okay. That's good right there.
Square. I don't see any cockiness going on there.
Yeah, looks good. Okay. Okay, so we're going to use our hockey puck again. Okay, and Lance is going to assist me. Let me get this.
Get me set up there? Okay.
Yeah. Okay. It's pretty good, but, you know, just make sure it doesn't fall.
Yeah, we don't. This is where your dead blow hammer really pays off. Doesn't pop it off the table.
Okay, Lance did replace the bearing die earlier.
Yeah, I switched it.
Yeah, he switched already, so that looks good.
So we're picking up the ID there. The OD, rather. We're going to... No, the ID. Yeah, both.
Yeah, both.
Sorry.
Let me just move this right there. Okay.
That better?
Yeah, it's better.
Nice and solid.
Okay, yeah, you just want to be really careful because, see, we're inserting it down the spindle shaft, but then we also have to contend with the outside diameter, the housing. You know, we don't want to have it off-centered a little bit and then pound the side of the bearing into the wall, the housing. So just take your time. Okay, so it now went in.
Remember, our tool's covering both the outer and inner race.
That's right.
Equally.
And see, actually, yeah, this is really important. Let me show that. See, Lance is...
That's what I've been trying, yeah.
Yeah. See, if you notice, this die is completely flat, and it's actually hitting both of the bearing races, the internal bearing race and the external bearing race. And that's really important because in this case, we actually have to press on both races at the same time because there's pressure getting the bearing onto the spindle shaft, and then there's pressure getting the outside bearing race into the housing.
Yeah, a little
bore.
bit. Mm-hmm.
Yeah, a little bit. Not as much, so...
Not as much, but nevertheless,
yeah.
So precision.
I think that's good. Here, make just one more.
Always.
That's good.
Let you do the honors. I'm not going to do it.
Okay. Okay, as you know. Oh, yeah.
You like that?
This is the ultimate test because now we've got all the bearings installed.
Any binding that was going to happen in this housing on both ends. Both the bearings are both in both ends, two separate cavities. You'd have it right here.
That's right.
And the spacers are not a factor, but that...
Doesn't that feel good to
Yeah,
you?
it's really nice. I can't wait to turn it on. Do my break-in and all that. I can't wait.
Oh, yeah. See, that feels good. Feels silky smooth. Nice resistance.
Boy, they were due for an update, weren't they?
Oh, yeah. It's hard to believe, you know, after you do a rebuild, it's hard to believe that your headstock once felt like this.
Yeah, because that's not what it was doing when we got to this point. They weren't bad. They were just not smooth anymore. They've got a lot of hours on them.
That's right. Okay, great.
Beautiful.
Okay, we're done with this section.
Oh, okay.
So we're going to close this section off, and we'll be back, and we're going to finish the spindle assembly. You know, that entails the belt pulley, the spindle nut, and also the plunger to lock the spindle.
Oh, okay.
Okay, so we'll be right back.
Right. Part 3C, Section 4, installing the belt pulley and spindle nut with some added bonus footage of a special event. Patrick, would you like to elaborate on that?
Sure, because before we can install those two parts, there's actually something else we have to install first, and that's the plunger lock. And that's what you push in to lock the spindle.
Well, it has that indexer when we installed the bearings, huh?
That's right.
It's like 6 positions or something?
Yes. And just real quick, I'll show you where it's at on the drawing. It's this plunger that installs right in front of the headstock. And see, you can see where you push that in and it locks into the spindle right here, into the collar, the locking collar.
Oh yeah, sure.
So, and the reason why we have to install that now is because we're going to use that to lock the spindle when we install the spindle nut.
Oh, that's great.
So it's really nice because, like we mentioned, you know, unlike the open style headstock, on the closed style headstocks, it's a really rugged design, so you're safe.
Yeah, it's very aggressive diameter pin, and it's got a lot of little parts, so I'm glad you're going to assemble it and share that with everybody.
Yeah, I wanted to do that because I know earlier we showed this all assembled, and I decided to take it apart because I wanted to show people there's actually a lot of little parts that make up this assembly. And this is really important because if you haven't already done so, you should have taken this entirely apart as shown, cleaned it, you know, really well, and then you want to oil all the parts. So I'm going to do that really.
Now I cold blued those parts for you because
yes,
we want to give this whole. We did all the paint work and everything, so.
That's right. See how nice and blocking or blued it looks? They call this a chemical bluing process. And you can see it's really
It's not
nice.
mandatory. It's not required.
Cosmetics.
We just want to do things because we got this chance to stop. So that's what we're going to do it by the book. Well, we do a lot by the book, but okay, by the book. A little dab goes a long ways.
That's right. Just a
Don't want it all full of oil. Just one.
It does a really
coating.
thin coat, right? Okay, this one, I like the pin can have a little bit extra oil. It's a moving part, yeah. Right? Okay, so remember, so this cylinder gets inserted into the headstock. So then we want to insert this with the pin first. So just like this. Okay. Just a teeny bit of oil on our set screw. I'm just using the oils for my fingers for the spring and the ball.
It's a little ball bearing, yeah.
Yeah. Okay, so make sure the pin's fully inserted. We want to put the ball bearing in first into the set screw hole. Spring. And our little set screw. Okay, that's good. Okay, I just want to test it.
That's your little plate that keeps
Yeah, be sure when
pulling past.
When you test it, be sure you put this little plate in the front because that's what hold the pin from pulling all the way out. Because without that, you're going to be able to pull the pin out, your spring, your ball bearing, everything's going to pop out.
And go who knows where.
Exactly.
That sounds good.
Oh yeah, feels good.
We want resistance here now, right?
That's right.
Because we don't want that to vibrate harmonically or something while the spindle's running and then close in and snap and get grabbed by that spinning slotted 6 slots position.
Exactly.
Indexer there.
Yeah, that would really be a terrible problem. That would be really bad for the spindle, I would think. Okay, so that's good. So make sure we pull it out all the way. Okay, at this stage, let me just add a little dab of oil real quick on the screws. So I insert the screws. Okay, we don't install the ball yet. I'm going to show you the technique we use for that.
Here I come.
Perfect, thank you. Okay, so there's our hole right there. Okay, so what I do is, so we want to insert this all the way. So I push the screws back.
Oh, and talk about your set screw positioning, I think.
Oh yeah, thank you. Okay, see the set screw? you want to insert this so that way we don't want the set screw pointing up. We also don't want it pointing toward the front of the spindle. So we point it about the 7, 8 o'clock.
Points toward the back of the pulley side of the spindle, and we just think it's the least chance of an issue.
Yeah.
Loading up, filling up the little keyhole with all the junk and stuff.
Exactly.
From the environment.
And also looks better cosmetically too, you know.
Having Jess around here. Yes.
Okay. Yeah, so see, I inserted it completely. You want to push it completely in, and then you can tighten your screws. Yeah, because sometimes what happens is if you don't push it all the way in, sometimes the screws...
It's a very snug fit.
Yeah, it's so tight that sometimes you won't be able, if you start tightening the screws, you won't be able to push it all the way in.
And screws want to make it back out and stuff. It's just, and then it's got that pin going, that sleeve of that pin going in the hole there too, see?
Yeah.
So it's a pretty snug assembly. It's very secure when it's done.
It really is.
It is the strongest Levin locking mechanism they have.
It is.
This is it. This is as big as it gets.
And yeah, you want this really secure. Okay, that's good.
Our little Rudolph, the red nose, is coming soon.
Okay, this is how we do it. What you want to do is, okay, so you want to push it in. So you want to push this plunger in so it engages and locks the spindle. Okay, so now it's in that collar. So then what I do is I turn the spindle to apply pressure.
To the pin.
To the pin. See, the pin, I can't pull it out, or I can't even turn it because I'm putting pressure on the collar. And then this is our opportunity to now we can screw on the ball, because the ball
really
doesn't
nice.
Yeah, because the ball doesn't have to be on super tight, you know, just snug.
It looks nice in red.
Yeah, doesn't it?
Yeah.
Yeah, that's good.
It's a nice look. How's it feel? You like that feel?
Beautiful. Just like, you know, there makes. Oh, I didn't. There we go.
Okay, I know. Oh, I like that.
Yeah, see?
It's a nice sound. Listen for that. See, listen to that sound.
Yeah, so you can even hear it when it engages.
It's real sure of itself.
Perfect. Okay. Okay, next, the next part is the belt pulley. And then make sure you put your little key in. Okay, but just want to apply a little coat of oil.
This is the second and last key of this assembly, isn't it? There's just two.
It is, just two keys.
The one in there that's on that indexing.
Yeah, it's really interesting. The bearing spacer doesn't get a key, but the locking collar gets a key, and the belt pulley gets a key. And what's really interesting is, if I remember on this one, I can't remember if this one, I believe the keys are identical, the same length.
Oh, okay.
Unlike the for the D closed style headstock, those are different size pins, which you'll see in another video.
The length's affected, huh?
Yeah.
Oh, okay. I like this particular pulley though, because of the way it's going to go out. I don't want to ruin that. It is neat.
Yeah. Okay, so what I do is I always place the key on the part first, and then I insert it onto the spindle.
At the bottom, I see, so the centrifugal force working in your favor.
Exactly.
Very good move.
On the collar, it was a very tight fit, so I really didn't have to worry about it. But on the belt pull, it's a little loose, so yeah. So I started at the bottom, so gravity keeps it in place.
See, there was my favorite thing that it just did, which was go inside the little
yeah, what I'm just talking about
counter bore there.
This belt pulley actually serves two purposes. It's it's a belt pulley, of course, but you'll notice it also provides a tight seal for the deep groove bearing. See, it actually goes inside the headstock. So it's really precision. Oh, and here, let me move this up. See, and then
still spins nice, huh?
Yeah.
Everything's still spinning.
So you can see our keys right there.
Oh, yeah.
And like Lance says, we always want to test it. You know, make sure, you know, from the installation of the plunger, now with the belt pulley, make sure it turns freely, no obstructions.
Nothing scraping. You should listen closely. No music in the background here now. You need to listen closely to what you're doing there.
That's true. You want to
hear
listen.
These snaps. You want to hear that spinning without any grinding.
And also the feel. Make sure it feels smooth. Yeah. Okay, so we're good to go. Okay, so now what we want to do is we want to lock the spindle. There. So we've engaged it, so it's locked. Okay, and now we can go ahead and install the spindle nut. Okay, and you'll see right here, you'll notice I've already removed the fastener. So if you haven't already done so, remove it now. It's just a good safeguard just to remove it, because you don't want to accidentally, you know, have it inserted and tighten on, you know, right here. And then what would happen is you would install, you know, your spindle nut, and you would mess up all the nice fine threads on the spindle.
That's just a good precautionary measure. It's just because it's going to be a little too aggressive and be forcing that on there and be damaging.
Yeah. So again, just light coat of oil on this part. Okay, and just as an extra check, I just like to get my loop really quick, because this is a really precision ground surface right here, because, you know, that's what's, you know, keeping the whole assembly together.
I would hate to have some little pebble thing or something on there pushing up against that poor pulley.
Exactly, or even a hair or something, you know, that would cause it to go off center.
Yeah. Or
the pressure wouldn't be, you know, even around the circumference.
That'd be nice, yeah. That'd be terrible. All these little details, they add up to one fantastic ending.
Okay, and what I always like to do on very fine threads, I would like to go reverse just to feel the threads engaged, because I don't want to cross thread.
That sounded nice.
Yeah, did you hear that?
Yeah, I heard it.
See, now I can move forward.
Safely.
Now let me do this. I always like to just add a little, on the threads, just a little.
We'll never get a bad answer out of me about that. The more the merrier to a point.
Okay, there we go, engaged.
Oh, it's looking really nice.
Okay, now for the spanner wrench, okay, unlike the other Levin spindles where we had to use a spanner with a pin diameter of 1.5 millimeter, only for the 3C collet spindle, we can use a spanner with pins that are 2.5 millimeter in diameter.
We're going huge here.
Yeah, really huge.
Mm-hmm.
Okay, let me do this. Okay, so I'm good. I'm just looking around, just make sure. Okay, it looks really good.
Things feel good still, so.
Yeah, okay, make sure it's locked. Okay, just a precaution, I like to just keep pressure on the plunger. Just make sure it doesn't pop out or anything. It shouldn't, but, you know, again, just precautionary.
And we don't go to town here.
Yeah, just snug.
We got a locking screw.
Yeah, just snug.
So don't got to go applying a bunch of pressure to that poor locking pin and all that.
Yeah, it feels good.
Isn't that nice?
Oh, it's stuck. No, I'm just kidding. You don't want to kid, huh?
No.
Ah, it feels silky smooth. Want to give it a test drive?
Oh, yeah.
Doesn't that feel nice?
That's a nice, it's just beautiful lock. The way this locks in, I'm telling you, you could machine marvelous parts with that.
And I know we keep...
Spectacular.
We always repeat this when we're at this stage, where, because it's just, it never gets old, but the feel is just, I mean, there's absolutely zero play. You can't feel any play, but it's just so silky smooth.
And while we haven't gone to break in yet or anything, we're at a stage where we've put a boatload of time and effort into this project.
Yeah.
And so we're feeling great results at this time, even though we haven't done past the break-ins yet. That's the thing. But it's at this point, it's feeling like it's really on a great course.
Oh, yeah.
So yeah, we're a little bit excited. A little over the top.
Okay, so now we can put a little fastener on. So,
Mm-hmm.
still oil.
And that's, can I speak?
Sure.
That spanner wrench is covered in the tool list on the activeatom.com website, right?
It is.
The downloadable documents that we have there.
But no, it feels great. Okay.
Lock that in there.
Yeah, the fastener's secured in there. Again, not tight. What you're doing is, so if you look really closely, so you see that slot in the spindle nut. So what happens is when you tighten this fastener, it's bringing, see those two parts closer together, and it's applying pressure on the threads.
So first we've got it in pretty snug against the back of the pulley.
Yeah.
And then we've got this screw squeezing the threads a little bit.
Yeah,
and that's a double locking system, basically, to keep really going to secure it for the long haul. Yeah,
for many years. So that way any vibrations or just in use, it's not going to back out. The spindle nut, that is, isn't going to back out at all.
That's a good
It's really secure. And yeah, so
it's just looking wonderful.
Yeah, so I think we're good to go at this stage. So what do we have left? This closes this section, and I think we just have one set of parts left, and that's the slinger cap, and then the hardware for the bottom that secures the headstock to the bed.
That's right.
So okay, so we'll be right back.
Part 3C, Section 5, Installing Slinger and Mounting Parts. But before we do that, I just need to reiterate one thing here.
Sure.
We keep talking about this tool and that part and this lubricant and that thing and this and the other.
Yes.
And I thought, well, you probably ought to explain what that is. You know, we have a website, activeatom.com, and there's something there, isn't there?
Yes, there is. Okay, if you go to our website, for our whole Spindle Rebuild series, we have got a variety of documentation forms. And what you want to look for that Lance is talking about is a parts and supplies checkoff sheet. And that details all the tools and supplies you're going to need to perform a spindle rebuild.
It beats stopping videos and writing down notes.
Yeah, because instead of writing down every little thing.
Who wants to do that? You got enough to concentrate on just following along with the fine details that we're performing here.
Exactly. Okay,
I just wanted to do that.
Sure.
We were talking about that spanner and this and the other. We probably better reiterate that.
Right, especially for the 3C headstock, you can use the spanner with the larger pins, and that's really important.
Which is really nice to get to do once in a while.
Yeah.
Oh, well, thank you. Okay.
Sure. Okay, we're almost there. We've only got a little handful of parts left to install for this procedure. Okay, I've got all the parts here. And I'll start off with this one.
Great.
We've got the actual slinger.
Zing!
We've got the slinger cap. We got the fasteners to secure.
Brand new hardware.
Yeah, brand new hardware to secure the cap. Okay, then over here, we've got the clamping hardware. And this is the hardware that clamps the headstock down onto the lathe bed.
And it really, really holds that headstock to that bed and makes that one unit.
Yeah, this is
amazing.
This is designed really well because when you tighten your headstock down with this hardware, it's not going to move.
It's the last thing you're going to need to be worrying about.
Yes.
Yep. Okay, great.
Okay, so what we're going to do first is we're going to install the slinger and the slinger cap.
Great.
So let's get that started.
You want me to help out?
Sure. Let's see. Okay, real quick. Let's start off with our slinger. Okay, the slinger itself is just aluminum, so we don't have to coat this with lubrication at all. Well, I'll get back to that, but what we want to do is add a light coat to the head of the spindle.
Perfect.
I also do the back since we're kind of wrapping this.
Oh yeah, and can I just mention, because we did it off camera,
Oh, the witness marks.
the witness marks from the high spots that we had on the spindle. We removed them already.
Yeah, that we made with a permanent marker. Remember, we had the witness marks on both sides of the spindle. What we use is isopropyl alcohol. and we just clean, you know, it actually cleans, because, you know, we're constantly testing the spindle as we're adding parts.
Yeah, one was about wore off in the back one.
This one was about worn off, right. So the isopropyl works really well, cleans the witness marks off and just gets these clean again. But the problem is it strips the lubrication off.
So you've got to follow it always with oil.
Yeah.
In this case.
Exactly.
I just wanted to mention that because we did it and said, oh, you know, there wasn't much left to witness.
No, not on this side.
That's why we marked both sides. So if we lose one, we have the other.
That's right.
Fantastic. How's that feeling?
Oh, great. Very nice and smooth. Okay, good. And then I just like to add a little bit of oil on the inside, just. Yeah, because yeah, we've talked about this before. You know, any situation where we have two parts that seat, you know, together.
Right.
We've always seen a common issue, and that is rust and corrosion.
Or just that, even that discoloration of the metals that
comes
in there. It's not like a funny corrosion.
Yeah.
It's not a measurable corrosion. But it is. We know, but everybody knows what that is, I think.
Yeah. So it's really important. You know, you want to always keep. You know, make sure there's lubrication between any two parts.
Very good.
Okay. And this is, okay, really important. You'll see, so you'll see the collar right here, and then the actual slinger, you know, which is the larger diameter. And when you install this, you have to make sure that the collar goes on first.
There's enough room for it to slip in there, believe it or not.
That's right.
Right along that spindle body.
So what I do is I try to use my fingers.
Yes, you can, because it's just a soft aluminum.
Yeah. Okay, and then what we use is, okay, you'll notice when we did in part 3B, when we assembled the Levin open style headstock, we showed you two methods to install a slinger. And the first method was using a socket. From, you know, your socket.
Oh, from your basic automotive or general machine shop area, those sockets, you know,
that's
we're all familiar with, the Craftsman's or whatever, snap-ons, you know.
Exactly. And if you use that method, what you want to do is you want to use a socket that's just a little larger than the diameter of, you know, the head portion of the spindle, but not, you know, so just a little larger than that. But not too large, because you want the surface of the socket to press onto the slinger.
But I got a footnote here, and just a cautionary tale as the person who polishes so many parts around here. That spindle is a beautiful finish on it. And I just don't like the idea of getting that hardened steel near there with those grooves.
Yeah, we actually don't recommend it.
And so that's where you have something fun.
But we got to provide a solution for those.
You do.
You know,
then who wants to go do this for one day?
Yeah, because see, in our case, remember we had to make that tool because the two angler contact bearings at this side of the spindle, it was such a tight fit. You know, usually you can push those bearings into the housing with your fingers, but in some cases it's such a tight fit, and that's where you're going to have to make a tool like this. But what's nice is this tool serves two purposes. It also allows you to press the slinger on.
Yeah, so if you're doing the 3C, I guess this is a good deal.
Yeah. And if you notice, that was the other solution on the open style headstock. We made a tool like this. It was much smaller because it didn't serve two purposes. It was only a tool for inserting the slinger.
Yeah.
You know, but Delrin, we use Delrin a lot. It's really easy to machine, but more important, it's soft where it won't damage.
It won't hurt
any
the
of the
steel.
parts.
Yeah.
Right. But it's tough too. You know, it's not.
Yeah, you can hit on it. We do all of our bearing tools are that way around here. A lot of them.
Okay, so what I'm going to do is we're going to use our hockey puck.
Right.
Okay, and Lance is going to help me with this, just so that way the headstock doesn't fall over. Okay, so I'm just going to place this here. Okay, and I'm just going to use our little dead blow hammer, and just very lightly. It shouldn't take that much pressure. Just go around in a circle, make sure.
Yeah, real equal.
Yeah, looks good.
It's a heavy little guy.
Yeah, it is.
I like that look.
Okay, it looks perfect. You guys see, it may not be perfect because this is aluminum. You know,
Right.
it's just aluminum sheet. So, you know, but you can see it's all fully inserted and looks good. More important is you don't want this to rub on this bearing cap. And especially when you install the slinger cap, you don't want it to rub on this either. So here, we'll just give it a quick test. Yeah, perfect. We both listened.
Yeah, I want to make sure I don't hear anything.
Yeah.
This is it.
Yeah, perfect.
Great.
So definitely, yeah, so that's all we need.
It's nice. Looks nice on there.
Okay, just make sure it's on. Oh yeah, no, and as always, you know, give it a test spin. Make sure.
Anytime we've been pounding, especially when we've been pounding on it,
Yeah.
even if we haven't touched it.
Okay, that's how it looks.
It's nice.
Here, actually, have a little witness mark on the.
Was there a little left there? Oh, on the slinger?
My slinger. Okay, there we go. Okay, before we install this, let me just oil it real quick. Okay, this is where you got to pay attention because we see these get installed incorrectly all the time. Okay, you'll notice there's a slot right here. And when you install this, you want to install it where the slot is pointing down.
Straight down.
Because what's going to happen is, see, the function of the slinger is if, you know, a piece of foreign material makes it through the slinger cap, it's going to hit the slinger and bounce it off onto this wall of the cap. Okay, and hopefully with gravity, that particle is going to drop and exit the slot.
Even such as coolants and things as well.
That's right.
That's going to just wash it right down there, but it'll never get past that slinger. That slinger's
Exactly.
snug to that spindle right there, and then loose on the outside. It's really neat.
Yeah, and see, the problem is we see these get installed all the time, you know, with this on the side, you know, up like this. And the problem is what's going to happen is gravity is going to pull that material
And facing up,
down.
It's going to invite more stuff to fall in there like a coin slot.
That's true. It's going to, right. See, and all your foreign material and particles is just going to accumulate on the bottom.
And that's going to find its new homes, and you don't want that.
That's right. Let me just...
Mm-hmm.
Yeah, I think we're good. Okay.
There's nothing more exciting than new fasteners, isn't there? I just get a real joy out of them.
Oh, yeah. I agree.
They look nice. They feel nice. They're just nice. Now, unlike the last cover you put on here for the actual bearing cover, that one's held with force. It's held with a force against the bearings, right?
That's true.
And this one's just mounted flush up to that.
Just flush.
The outer one's mounted flush up to that one. We're not expecting any kind of, we're not looking for anything here. Except
That's
a nice
right.
flush mount.
Exactly.
Perfect.
But, you know, just out of habit, you know, anytime you have multiple screws like this, you know, at first I first, you know, place all the fasteners just really loose. You know, I'm not going in all the way.
See how it's fitting, how they feel.
Yeah.
New screws and all, what have you, you know.
Yeah, so just really light. Okay, there. I back off a little bit. Okay, then what I do is just like installing lug nuts on a tire again.
Okay, star
you
pattern.
know, the star pattern. So top, bottom, up. And again, like Lance said, you know, this cap's not holding, it's not putting pressure on anything, so you don't have to go super tight with it. But
It's
just
just a
snug.
last wall of defense protective cover, actually.
That's right.
It's nice. It's a great design.
Okay, now with that on, give it a test spin. Okay, nope, don't feel any obstructions. Okay, listen with my ear. Nope, I don't hear any sound.
Isn't that beautiful?
Want to test it?
Of course.
Okay, this is really important because okay, the spindle assembly is officially 100% completed. So this is the important part right here, testing the spindle, because we don't have any more parts to install. So we're done with the spindle assembly. So if you made it this far and your spindle still feels silky smooth, no obstructions or anything,
we're in a great position getting ready to move forward to the break-in.
That's right.
Oh, and it's getting more and more exciting in this room.
Okay, great. Really good news. Okay, so let's install our mounting hardware. Okay, as you can see, we've actually already oiled these parts. Actually, Lance did.
I blued them and then I cold blued them and then oiled them, including the springs.
That's right. Okay, but what I like to do is, especially on these bolts, I just like to add a little bit extra oil, especially at this eccentric surface.
Sure.
Yeah, just to make sure it turns really nicely, and then there's going to be pressure right there. Yeah, these came out really nice. The bluing.
I like it. Yeah, no, I working really nice on that. So I'm hoping it's nice to have the extra time to get it all right the first time.
Yes.
It's a good feeling in the end. It's just a rewarding system there.
Okay, great. Okay, so this is what I do is I always work one end at a time. So here I'll put one spring in first. It's a little. There we go.
Take a look at that one while you're doing that there.
Okay, when I insert this, okay, remember the bolt's gonna go in. So we've got the holes right here for the bolts. So we want to be sure the hole on the clamp is facing. So we're gonna push this in, seeing it's spring loaded. See how it automatically comes up.
Makes it nice.
Yeah, make sure you can see that. See? So when you put the bolt in, you just have to push it down a little bit, and there it goes right in.
It's just the part of the spring there is sticking a little bit. It's okay.
Yeah, sometimes the spring can be a little tight, but
a little unsprung.
Yeah, as long as it works. See.
Yeah, it could have been from my reworking and bluing and all that. So nothing to alarm about.
There we go.
Isn't that nice?
Okay, here, let me just test it real quick. Okay, here, let me, just so you can see.
You got it?
Yeah, see if, I hope. Okay, see when I turn it, do you see it going in now? Yeah.
There you go, that's neat to see.
Yeah, see that one too?
Like a little piston.
Yes.
Acts like a piston. Like running on a cam.
Okay. I always set them so they're completely out, so that way it's ready to be installed onto the bed. Okay, there. Okay, great. Okay, we've actually, I'd like to say it's 100% done, but there's actually one part left, but we can't install a part yet.
Cannot.
And it's actually the belt pulley cover.
You see your pulley comes out both bottoms there.
You see, the way
or the back.
Or the back.
In our case,
see, in our case, the belt pulley, comes in the back right here, or at the bottom.
Sometimes the motor's mounted under the table.
I'll tell you, since we're talking about this, actually, when Levin makes this part, they don't actually make it with a slot in the back. So if you need to order a replacement, or you may have an existing headstock that maybe where the motor's on the bottom of the table. Well, if you need that opening in the back because you know you're going to have the motor on top of the table in the rear,
things around, yeah.
Yeah. Levin actually doesn't sell it with this slot. You actually have to mill this slot yourself. Yeah. And we actually do a Shop Adventures. I think it's actually Shop Adventures number 2. If I'm correct.
It's early on, yeah.
Yeah, really early.
You'll see this cover in the thumbnail.
That's right.
Is that where it was?
In the thumbnail.
It's right there.
That's right. We show the front, I think.
Yeah.
And because on one of these, we replaced it, and I was really surprised when we went to order it from Levin.
It didn't have it.
I asked Levin, I said, I need the one with the slot in the rear, and they told me, well, we don't make it.
Yeah, you may need it, but that's sorry.
Yeah, you have to mill the slot yourself.
So we did.
Yeah, so we did, and we show you how.
Yeah, we did that on our little CNC mill.
Yeah.
That was neat.
And see, this after, and see, you don't want to install this until you get this installed in your bed, get your belt fused.
Yeah.
And then you can install this. See, it just goes just like this, just in the back. See, just like that. Nice. And then you have the 2 fasteners right here.
And that'll be it. That's how it looks all day long.
That's right. So, but since we can't do that, we're done.
Right.
So part 3C is officially done.
That's it.
So we won't be showing the break-in procedure because
no, we've done that.
Yeah, in part 4 is where we share the break-in procedure on the open style headstock, and because that applies with all the Levin spindles, we aren't going to reduplicate.
Hey, we even made you a neat little downloadable form to fill out each hour. Each 5-minute segment, you're gonna chart your temperatures and get your readings. It's really neat process to take, and it's a lot easier with that form. Which I had that many years ago.
Yeah, it's the break-in procedure form, and it's really nice. It allows you to chart all the different temperatures and
all the different RPMs. Yeah,
that's right.
It's done really well, and I'm now proud to be. I'll be using it for my first time.
That's right.
As a download, I'll be using my downloadable document. All right. Part 3C. Section 6, final thoughts. Well, that is a final good feeling in it.
It is.
We have one last little thing that takes place, but it has to wait, doesn't it? Past the break-in, it's the last thing we do. In fact, the first YouTube video we ever made, we had to build a new install a new tabletop on a Levin workbench, which is an official Levin workbench, but not that top. We wanted to change it to maple because movers had destroyed it years earlier. Yeah,
because the original from Levin's a laminated top.
Yeah, we don't
like laminated tops.
It was really popular in its time, though.
It was.
And it's real clean and easy to keep clean and oils and stuff. What? But nevertheless, it was warped and ruined, but it had a little plaque in the front.
It did.
And under the thing we now call perfect shock ethics. Our etiquette here is, it's our final it's like a signature plate.
That's right.
We reinstalled it on there that day we finished putting the new top on. We installed a little placard on there, and that one took 2 little nails. But Patrick's here to explain how the process works for us to do these little plaques. Everybody knows these little plaques, right?
Yeah, on any Levin headstock.
Or most machine reading tools. And
some of the accessories. Oh, and from other manufacturers as well. You'll see these metal plates. And see, on Levin, all the plates look like this, are similar. And they're held in by 2 screws. And you can see the holes right here. And what they use to hold this plate, they're called drive pins. And they look like little tiny miniature nails. But they also have almost like a thread to it.
Yeah.
You know.
Like a corkscrewish look.
Yeah, like a corkscrew look.
Yeah.
But we really hate using these
to death.
And I think everybody else does too, because you're mentioning that so many people leave the plate on, they paint around it.
They just mask it off and go right around. I don't blame them, actually.
Because these pins can be really difficult to remove. So when we remove them, what we do is we go ahead and we tap these holes so it's threaded, and then when we install this back on, we use little miniature screws. And that's so much.
I mean, they are miniature. But we're used to that.
Yeah, we're used to that. And what's really nice, because that way in the future, if we ever want to repaint this, it's so easy now just to, remove the 2 screws and the plaque's off. So
and that's our around the shop here, we're finished plaque.
That's right. It's our signature to, to say this is 100% done and ready to go back into service.
And it's a good practice to have, yeah. Really
yeah.
good. All right, well, that's it. I just wanted to close that up.
Yeah, no, great, because that really finalizes the whole procedure.
Yeah, and it doesn't get that till after the break-in now.
That's right, the break-in. And also, if the headstock requires it, we will grind the collet seat.
Sure.
Okay, and if you want to see that, we actually do that in part 5.
Yeah.
And that's where we take one of these headstocks and we have to regrind the collet seat.
It's quite a neat task to follow along with. So.
Yeah, you don't always have to do it. There's only 2 conditions where you have to do it. The first condition is, if it's worn out, because a lot of times after a lot of use, from the collet going in and out on the seat, it'll form ridges.
Yeah, it gets a comfort zone.
Yeah, it gets a comfort zone. So it's really nice to just, give it a nice new ground surface.
No.
Okay. The other thing is, prior to doing the break-in, we do take a really high precision test indicator and we take a reading off the existing collet seat.
We sure do.
To make sure, to get it like a baseline reading to see what our accuracy is. And if the accuracy is not within, what we like to shoot for within the factory
tolerances. And if we can't bring it back to that, there's no reason to go forward. We need to stop.
Right.
In our case.
In our case.
We're not willing to accept that.
Yeah.
We'll get a new spindle, whatever it takes.
And remember, the factory tolerances is 50 millionths total indicator run out.
It's a little close.
Yeah, so it's really tight. So, okay, great. I think that completes everything.
Thank you.
Okay, thanks.
As watchmakers and micro machinists, Patrick and I thank you for following along with us while we take this journey. We look forward to bringing you another exciting show shortly.